I am Aachman, and well, that happens to be my username on every major platform, so you can follow me there. I discovered Flutter back in 2019, and I immediately fell in love. It was my first framework and has been the only framework I use for making apps. After playing with it for about a year, I joined this startup called Codelessly that is a platform where you can drag and drop components onto a canvas to build full-fledged Flutter applications like this. I was there for about 3 years before I took a career break. It was really exciting though. Apart from this, I have um, contributed to the Flutter community by writing articles and producing courses with these publications. My writing projects aren't limited to technical writing either. Um, I have this newsletter called Weekly Meditations, where I share one personal essay every Sunday. The topics go as far from tech as possible, so you can think travel, philosophy, and even poetry sometimes. It took me half a decade to realize that I was living at this intersection of programming and writing. I love making apps and I love the craft of writing. So I thought, why not do something in this space? And from that, my latest project, Ingenuity, was born. It's a platform that supports your writing from that first spark to that final draft. I am making it in public and I document everything here at inkandcode.substack.com, so you can check that out to follow along this journey. But in 4 simple steps, Ingenuity helps you think, you can take notes, and you can refine your thoughts by talking to an LLM. You can research with it and organize your research as you're writing your piece so that you can refer to it while writing. And the UI essentially disappears when you write, so you can focus on your words and get to that flow state easily. Once you're done with your first draft, you get a whole suite of editing tools for grammar, for fact-checking, proofreading, and an AI editor whom you can ask deeply contextual questions like, hey, is my character's arc consistent between chapter 3 and chapter 8? You will get the answer because the app knows everything about your novel. Now, why am I telling you all this? This is not a talk about my app, but about crafting OS-level experiences with Flutter Desktop. However, this context was important because what we are going to build today is, in fact, a part of Ingenuity. Let me show you what that is. So here I have Ingenuity up and running. This is the main writing space. Yeah. So this is the main writing space. I have stripped out most of the components so that we can focus. And this is a piece on good writing by Paul Graham. Excellent piece, by the way. Now let's suppose I was writing this essay. I am in that flow state, just jotting down words. And suddenly, I have a question that needs to be addressed immediately. Instead of Googling or opening up ChatGPT, I can just press Shift, space. And this pop-up appears, and I can ask my question, what does Ingenuity mean? And I will get my answer, and I can just get back to writing. But what we are going to do in this talk in the next 70 minutes is elevate this component to the OS level so that it doesn't live in the confines of the main apps window, but can be popped up from any application. So you can ask your questions no matter where you are in the OS. If that sounds interesting, let me show you the progression we are going to follow in this talk. So we'll start with this generic app window and give it a custom frame. Then we'll have a secondary window pop up so that our command palette is independent. Then we'll remove the entire frame and make the background transparent so that it appears floating above other applications. And we'll turn it into a background service. So the taskbar icon moves to the system tray. Then the next natural progression is using global shortcuts to pop this open. And finally, we will integrate OLAMA for offline AI support, so we get our answers. But we won't stop here. We will extract the underlying OS accent color and give our palette a shade of it. And the other enhancement we'll make is adding this context button, which many apps use like Cursor, Gemini. So you can upload a file like so, and your answers will be deeply contextual and not generic. So here it tells me about Ingenuity app and not the word meaning. Uh, okay, we have a lot to cover, so let's get started right away. First, we have custom frames. They give a personality to your app. It separates out your app from a vast majority of generic-looking apps. So to do that, we'll use this plugin called Flutter Acrylic. It enables those window effects, translucency, and gives us some control over the window. But to get a complete suite of controls, we have Window Manager plugin, which lets us set the size, title, make the app frameless. We can programmatically minimize or close the app. So let's just chat. I already have all the plugins installed for this talk, so we don't waste time. I go to main.dart, and first and foremost, we need to ensure that an instance of widget binding is available to interact with the underlying platform code. Then we can go to initialization.dart and implement our Flutter Acrylic plugin right here. Let me make the imports. All right. Then I'll just go to main, and in here, I'll call this initialization method. So now if I hard restart, our app should have a translucent frame. Oh, okay, maybe I didn't. Ah, okay, one import was missing. Okay, hard restart. Okay, so the frame is now translucent, but the background is still opaque, so let's just change the scaffold background. I'll go to workspace view, and in here, I'll just change this color to colors.transparent hot reload, and our app becomes translucent. It's really easy. However, we don't want quite this because it's not a good experience for a writing app. So I'll just pick a middle ground with alpha 180. So it keeps the paper like color but is translucent. Okay. We'll explore one control utility that this plugin offers. So let's just add window.hide control buttons, and I can again hot restart. So the thing with plugins is hot restart is what you will do most of the time instead of hot reload. So now if you see, the minimize and maximize buttons, all those buttons are gone. And that's it about Flutter Acrylic. Now let's gain a bit more control over the frame with Window Manager. Just a second. Okay, now we'll implement this method right here, initialize main window. And let me make the imports. Okay. So here, first we ensure that we have an instance of window manager, and then we define our window behavior using window options class. So here we want the title bar to be hidden. We want the window to be centered when it's launched. We give it a specific size, and we also constrain its minimum size so it doesn't go beyond that. Finally, here, wait until ready to show, which means when the window is constructed, we programmatically show and focus it. So now I'll just, again, initialize this method in our main method. Await initialization dot initialize main window. And now if I hot restart, and let me go to the, now it will be centered automatically. Yeah, so it is centered. The title bar is gone entirely, and it looks pretty custom already. But it's, okay, let's also check the minimum size constraints, and I can't go beyond this. Yeah. Now the next step is to add buttons to programmatically minimize and maximize these. So our custom buttons will live in the app bar. Workspace view, and I just paste the code in here. So window button is just a custom widget, and I install window manager. That's it. I just hot reload, and here we have our buttons. Let's check if they work. So yeah, that's pretty custom. We can also close the app. That's it for custom frames. We can now move to the next section. Let's get back to slides. Okay, multiple windows. So we want our command palette to be its own window, to be able to float above other applications. So to implement multi-windows, we use this plugin called Desktop Multi-Window, which lets us create and manage multiple windows. And it enables bidirectional communication via method channels. So you can pass data to a secondary window and also get some data back. And the best part is it already works well with window manager. So you can control the behavior of secondary windows as well. So let's just implement it. We are in workspace view. Okay, there's our to-do. So first and foremost, we need to create a window. So for that, we use window controller dot create method, and it takes a configuration, which is basically just two parameters. First, arguments. Arguments is to differentiate between windows at runtime. So when we we are deciding which window are we working in, we use arguments to locate it. And then hidden at launch false, because we want the window to appear as soon as it is created. Now I head back to the main method. And I'll just remove all of this code, because we are going to do something different. Now, when a new window is created, the life cycle loops back to the main method, because we are essentially creating a new Flutter engine in that secondary window. So we locate the controller from the current engine, that is the current window, and then and then we check for the arguments. So if the current controller's arguments are command palette, we run this app. If no arguments are present, we just run the main Ingenuity app. So at this point, I think I can just run the app. And now we should have the ability to open a second, the control, the question dialog as a secondary window. So while the app is building, we can explore the documentation of the plugins we are using. So these are the kind of effects that we get from Flutter acrylic package. Now sadly, there are very limited number of effects for Windows and Linux, but macOS users are quite lucky. So there are a ton of effects. And same goes for control utilities, only couple of them for Windows, but for macOS, the list goes on and on and on. So yeah, if you're a Mac user, you can use this package confidently. Yeah. Let's see if our app has built. It's taking some time. So if anyone wants to ask something, you can ask during this time. Yeah.
It means that suppose internet is there. At the time in the title bar, we have to add the one icon like a green button, green colored small image. If internet is in offline, then it will turn it on as a red. This kind of customization, is it possible to on window?
So one approach is to go native and have that implemented in the title bar itself.
Okay.
Or you can create an illusion, hide the title bar entirely, create the custom frame like we just created here, like the window controls lie in the app bar now. So you can put your signal widget in there, and you can get the Wi-Fi state from platform channels, which we'll just explore.
Okay.
And so you can either create the illusion or go all native.
Oh.
Both approaches can work.
Thank you.
Thank you. Okay, our app has built. And if I press this button, our dialog should open in its own window. Oh, sorry about that. Actually, since I'm extending the screen, it it opened over here. So yeah, it's now its own window. We can close it, and that's it for this section. We can move forward. The next step is to convert uh, this into a background service, which is more or less of an illusion again, because a background app is one that whose icon does not appear in the task bar. So if it doesn't appear, you can't interact with it, you can't open it. It's a background service. But to interact with it, we need to move that icon and the interactions to Tray Manager, to the system tray, using this plugin called Tray Manager. So it gives us control over the icon, pointer events like what happens on left click, what happens on right click, and also a context menu. So you have that menu, open the app, exit the app, or perform some custom program. So let's implement it. Okay. Uh, I'll just comment out all of this code. And paste this, because now we don't really need multiple windows. We'll just focus on the command palette and try making it as a floating window. So let's just import it. And If we hot restart the app now, it would build a command palette widget. Let's see how it looks. It's just a blank screen, because if we go inside the command palette widget and see how it, uh, like what it's doing under the hood. So it's just a container that is given a color of a translucent black. What we want to do is, whenever this window is shown, we want to pop up that dialog. So it creates an effect that, okay, whenever you click the app, you open the app, that dialog appears. And to do that, we will need to listen to window events. Uh, so we need to mix the widget state class with window listener. And I'll just add listener, and for best practices, remove listener. Okay, so since we mixed it with window listener, we are now listening to the window events. That includes window focus, window maximized, unmaximized, all sorts of stuff. What we are interested in is when the window is focused. So when the window is focused, we show the command palette. And this showing flag is just to make sure that the dialogues don't pile up in a stack. So when the window is focused, we show the command palette. Now if I hot restart the app, now I'll just open the window, and okay, so the dialog popped up on its own. Now if I just minimize it, focus it again, and okay, focus it again, and it, um, oh no, something happened, like uh, we need to move forward. This is an edge case. We'll get back to this case, and I'll tell you why this happened. But for that, I'll need to move forward and remove the background windows frame entirely. So let me stop the app and go to initialization, and this time we'll implement this code. Initialize command palette window. Again, we are controlling the window behavior. This time we want to skip taskbar, which means to hide the taskbar icon. We want to make the window full screen, and we want to make the background color transparent. And of course, title bar is hidden. Go to main, and again, the same steps, initialization dot initialize command palette window. I forgot, and await. That works. So now, if I build the app, okay, now we can again use this time to uh, explore a bit more of window manager plugin and see what all options it has for us. So these are again the window options we just explored. We saw this function and listener. So we can listen to on window event, which is a generic method, on window close, focus, blur, maximize, unmaximize, minimize, restore. So we have complete control over the window events. And one interesting method that this plugin has is set prevent close. So if you want to prevent your window from closing right away and show a confirmation dialog, like do you really want to quit the application, you can do that using this method. Again, I am open to questions if any. How about I ask one? In here, in this method, I have set the window behavior to be full screen and I have kept the background color to be transparent. The other option we could pick was to reduce the window size to that of the command palette. Why didn't we do that? What advantage this approach has, or is this the worst approach?
Now we have options. By clicking escape, we can close that window.
Yeah.
Okay. And other option can be if you are making a full screen one, then outside of that part, if we click, then we can close.
Hmm.
Otherwise, if we'll make that size only, then only one option will be escape to close that window. Otherwise, I didn't see any option to close that window.
And there will still be, because if you press outside the confines of the window, then the window is unfocused. And we are listening to the window events. Yeah, so we can listen to that event, and on unfocus, we can hide the palette and close the app. We can do anything. Okay, I'll take the answer again because our app is running. Uh, just a second. Uh, so here's a rookie mistake I did. I initialized the command palette window. I hit the taskbar icon, but I didn't move it to the tray, system tray. Now I have no way to open the app. It's just running. So we'll implement the system tray uh, first, and then we can get back to interacting with the app. So I'll just uh, stop it and start implementing the tray manager initialization. Make the imports. All right. So first we can set the icon, and Windows icons are in ICO format, and we are setting the tooltip. Next, let's set the options for our context menu. Here I give it a key and a label, ask a question, it will show the app, and I can exit the app. However, this does not work yet. It's just we have defined what the labels should be. Um, yeah.
The tooltip is coming right. So when we are pressing the on-click listener, where we can add it? Means on-click listener once the app is in background and in the system tray it will be showing the icon and tooltip. When we are pressing on it, right? So it will be coming out to the foreground. So how can we add the listener to that?
That's just the next step I'm going to.
Okay.
Yeah.
Thank you.
Um, so again, in the main method, let me call this initialization. Okay. Now, like sir said, uh, I'll go to command palette and start listening to tray events. listener, it's the same concept. Again, we'll add listeners to the tray manager and remove the listener from tray manager. Okay. So what should happen on mouse click? On left click, we should show the window. On right click, we will pop up the context menu. And we will listen to the context menu click events as well. So when show key is pressed, we show the window, and when exit key is pressed, we close the app. Now we can simply build the application, and we should see the icon in the system tray. Okay, now back to my question. If anyone would like to take a chance, or maybe you would like to take another chance. Hmm.
So while keeping widget in your widget tree, you're hiding it by keeping it, making the background transparent. At the same time, you can observe on focus and on unfocus and show your uh, whatever that window is.
So when I tap on the background, I am able to tap on the background even if it is transparent. I'm actually hiding the window.
Right.
Yeah. So I maybe I didn't get your
Yeah, right.
point of view.
So when you have written that code in main.dart, right, the command palette, right? Now you have we have to open the command palette, like either against a keyboard shortcut or a mouse click, right? At the same time, you also have to like press back,
Okay.
right? You have to hide the uh, the command palette window. So, and you have to have that so you have written that logic in command palette widget, right? Or have you written elsewhere?
It is in the command palette widget.
Right. So in order to observe like all these things, that widget has to be remain like in your widget tree, right? So when you start the app, you make the command palette totally hidden by like keeping the window background transparent, right? But at the same time, you can observe all these like focus and focus events on your widget.
Yeah, so that's what I'm saying. What you are assuming as a transparent background without the palette,
Right.
it's no background at all. The app is not there. It is in the it's in the OS background only. This transparent background only appears when the palette is also shown.
Okay. Okay.
Yeah.
Then I made it.
Okay, we'll again get back to it because our app is ready. Now, if you see, okay, uh, unfortunately, we can't really see the tray icon because my window is extended, but it is appearing somewhere here. Maybe I should um, duplicate it. I'll show it in the end, I guess, because I don't want to ruin this presentation. But I have this icon in the system tray now, and I can tap it to. Okay, I guess I'll just duplicate. Okay, so you can see the icon now, and if I tap it, I see this dialog. Oh, that's odd. I have no idea. This just happened when I duplicated the screen, and not really on my side. That's weird. Okay, but the basic idea is when you tap it, the dialog appears. On escape, I can close it, and this context menu works as well, and I can exit the app from here, um, like like so. Okay, what? Let me let me extend it again. And yeah, okay. Now we will have it pop up using a, okay. Just a second, something's off. Okay, never mind, that's not really important. We'll have it pop open using a global shortcut. So again, initialization, and we will initialize this plugin called Hotkey Manager, uh, like so. It's really, really simple. First, we unregister all the hotkeys to get a clean slate. Then we define our hotkey right there, show key, and then we register the hotkey and add this callback, just checking if the window is not focused, we show and focus it. So go to main and await initialization dot initialize hotkey manager, and I can just build the app now. Well, thankfully we won't need tray manager this time, so I can show it to you right here. No, the app needs to be running in the background. Yeah. Okay, we can explore further documentation of desktop multi-window plugin and see what other features it allows because hmm? Oh, you want to say? I should give the answer? Yeah. So I have some drop down.
Like you have the toolbar, right? The command palette.
Yeah.
In that you will search or anything. If you want to show any other UIs or any wizard for that, you are using that, the full screen.
I think yeah, you are getting it. The yeah.
And
Please.
also the effects, you want to have any focus effect or like your the palette should be little bit have some background, then you can use your full screen too.
Yeah. Actually,
Frequently, at the time we have to frequently change the window size basically. So that will cause a lot of jank in the app application itself. If you open in the full screen, then automatically like you can add any widgets into that.
perfect. So one answer, yeah, exactly. Your point that that widget can be variable. We have that flexible space, and also we can allow for animations. Like this dialog is actually a general dialog with a slight transition, so it only works in full screen. Um, yeah, our app is ready. Let's just hope it opens in here when I press shift space. No, wait, let me duplicate then. Okay. So I just, like my cursor is here, I just press shift space and this appears from VS Code essentially. So our app is effectively floating over the applications and it is running in the background. Now it's, we can, let's see if presentation is running. Okay, duplicate is fine, I guess. right, we were here. We could optionally scope to the app, the shortcut to the app also. Now we are done with plugins. What if our use case does not have an existing plugin? Let's explore approaches with which we can extend the whole experience while still staying in Flutter. So one is external process management. Basically, you can spawn these processes and interact with them, like creating a file via CLI or opening an app. But for this example, I wanted to take something trendy and seemingly complex. So we will integrate Olama for offline AI. Now it lets you run models on device, and it lets you start a server over which you can interact with HTTP commands. So we'll do just that. Let's go ahead and do it. First, I'll start a server, Olama serve. Now my server is up and running. Now to interact with it, I have this, I have everything wired in. I just need to implement the question call, essentially. So I can go in here. And copy the code. Right. Olama, for streaming, Olama follows its own convention of response chunks. So each chunk is a JSON object. So because it doesn't follow the standard convention for SSE events, I had to write this custom SSE client to support that. So it's just a custom function. Here is the host URL. Now that's pretty clever. So if you read it like 11434, it's basically LLAMA. And we are using the generate API. We could use the chat completion as well, but it suits our use case. Here we define the model, gamma 3, 1 billion. The prompt, we have set streaming to true. And a system prompt, just be concise. Context we'll get back later. So yeah, once we start receiving these chunks as events, we can check for data, and when we get this response, this onChunk method is called in UI to just update it with the response. And once the event says that I'm done, we call this onDone to stop, to hide the loader and stop the answer stream. Now if I just need to hot reload because everything is wired. I can ask my question, what does ingenuity mean? Now it's taking a bit of time because the first time you send an HTTP request, the model needs to boot up, but then it stays alive for a certain amount of time. By default, it's 5 minutes, so every second the question will ask, that'll be super quick. So we'll need to wait for a bit of time. Okay. Ingenuity, sorry, what?
You have shown initially, right? That paragraph is the context for the Olama?
No, it can be, but it is not.
Okay.
It's just this question.
Just normal
Yeah.
LLM.
Just
only.
this question.
Okay.
Yeah. So it just tells me the meaning of ingenuity. Okay, now it's working. Now the problem here is we can't ask the user, hey, start a server, and I want to interact with it. Our app needs to do it for them. How we can do it is by using Dart's process API, which lets us start processes and interact with them, run them to completion, or even kill the processes that we started. So it's actually very, very simple. I'll go to main. And before everything, our first step should be process dot run. It takes in the command, Olama. and a list of arguments. Here it's just one serve. That's it. It will start the server like we just did. Meanwhile, we should actually close it so that we can check. And starting is not enough. When we exit the app, the server should be shut down as well. So we'll go to command palette. And we are shutting down the application right here. So I'll just paste in the code. Here it is. So there's no default way to shut down a server. So we'll use this PowerShell command task kill and force the process to be killed. Now if I run the app, okay, it starts to build. And in the meantime, we have this local host of Olama URL, and we can see that the server is not yet running. So this is a nice way to check if our app actually runs the server or not. And when I said that Olama does not support standard SSE conventions, this is what I meant. So the response stream is this list of JSON objects. So it specifies the model and the response chunk. That's a fantastic question. And done is false until it is true. So we just need to handle this if we want to support streaming in Flutter app. Any questions?
Whether the server is already started or not.
It doesn't matter because Olama checks it internally. No two servers will be started. It's only one.
Okay, no, I'm saying like suppose like when you open first time, then the Olama server command is run,
Yeah.
and the server is up. Again, you are kill the app. At the time the server is stopped. But instead of that, like it should check. Maybe like you can run it in the background, right? If you want.
I can run what in the background?
Olama in the background, maybe if you want to.
Olama's own app?
Yeah.
Yeah, we can. Yeah, we can.
Yeah.
That's a separate process then. Okay, our app is up and running. Shift space. And I can ask my question. Again, it's booting up because it's a new server session. And we can, okay, let's just let it be because we will get the answer. It doesn't matter. In here, we can, yeah, because it's a background service. It remains throughout all the workspaces. No, I switched the workspace. Like, you can do this, right? Like this. So it remains open on all the workspaces. So I can run it from here or from like any workspace. Doesn't matter. So Olama is running on that host. Our app was able to start it. If we kill it, and I can just reload it, and it's stopped running. Let's move forward. So we have a functional command palette that answers our questions. Now we will enhance it in two ways. First, we'll give it some aesthetic enhancement by extracting the underlying OS accent color and giving a shade of it to it. For that, we can use platform channels that let us access access the hardware information and also the OS information. They act as a bridge between Dart and native code, and they offer bidirectional communication. So you can read information and also you can write to the OS. And we get static responses via method channels and also a stream of responses via event channels. So this one's gonna be a bit overwhelming, but let's get right into it. We'll go to Flutter window.cpp, and the first step is to get all the imports. Right, so DWM API, Desktop Window Manager, it's a Windows API that provides us all the information, including the accent color. We are importing that library. These come from Flutter. So uh, Flutter window is just the basic underlying engine. Event channel for streaming responses, sync to adding to the stream and for handling the output. Method channel, which we will use in this case, and standard method codec to encode and decode into JSON so that it's easy to use with Dart. Then we'll write our method. Okay, wait. Right. So this method get colorization color. This we get from DWM, and it's basically technical term for accent color. We are fetching the underlying color, and we are getting an H result data type, which allows us to handle success and error states. And then we static cast it to int to be used readily with Dart. So what we'll get is this format type, AARRGGBB. Next, we'll set up the method channel. Okay. So this right here is the channel's name, which Flutter uses to locate the channel. Standard method codec I just explained. It's meant to be used to encode and decode between JSON. Method call class allows us to get some method details. Like here, I'm getting method name to check. Okay, if the method name is this, then then I execute this program. Else I just result in error. And similarly, method result is used to check for success and error states. This method name is also going to be used on the Flutter side to locate this method. Now we can go to command palette.dart. The window side of things are done. We can move to the Flutter side now. So here I get the method channel by specifying its name, and I then invoke the method and expect a data type in return, and it's the same name like we just defined here, and I'm defaulting it to black as a fallback. Then we need to update our on window focus override, like so. So essentially, we get the accent color right before we show the palette. So even if the user changes the accent color, we always show the updated one. Now I can go to quick question. Okay, wait. Like, so we provide the accent color to the show command palette method, which under the hood passes it to our quick question dialog widget. And here we just need to update the background color like this, lighten color. this is a custom method that lightens the color because we don't want to give the exact color. They are pretty bright. This will lighten it by a certain amount, in this case 40%. And I think we are done. We can now run the app and see if we actually got the device accent color or not. What can we explore now? So, by the way, Flutter's own documentation is really, really good if you want to learn platform channels properly. They have explained all the uh, life cycle and all the flow, and they have given an example for all the native code for Kotlin, for Swift, for C++, and they cater to Mac OS. So I think they have given individual examples. Yeah, so iOS platform specific implementation, Windows specific implementation. So yeah, do check that out. Okay. We are almost there. After this, just one step remaining.
Like
This is a future.
if I change in real time, then like the app is launched, it has got the
It
accent
it
color.
won't work. I'll have to like you will have to reopen the dialog.
Other apps too, then.
For that we have event channels.
Yeah, yeah.
So that they return a stream of data.
Okay.
And you can find the example in the documentation I just shared.
Okay.
Yeah. So if I say accent color, I mean um, I'm in this color right here. It's orange for me. In fact, I can go to my device settings, personalize, colors, and here it's selected as orange. So we should expect an orange command palette. Okay, our app is running, it's in the system tray. Let's hope it works. It is a shade of orange. And if I change it to, let's say, this one's good, iris spring. So see how this switch changed here, and I can press shift space, it's purple. So that gives a native and a personalized experience for users. Now to the last step. Foreign function interface, which will let us enable this functionality to add additional context by uploading files to our app. So foreign function interface lets us interoperate between languages. So you can call methods from C, you can call from Rust, from Python. And the beauty of all of it is we can leverage existing library ecosystems in other languages. So if Flutter does not have a plugin for a certain functionality, you can use Rust or any other language for that. And if you have some computationally heavy task, you can always write your code in C or Rust, and you can optimize your app's performance like this way. So whenever I was looking for, just a second. Right. So when I was looking for examples for this talk, I realized that Flutter does not have a plugin to convert between various file formats. Like I can't really upload a doc file and expect an HTML in return. And LLMs depend on either Markdown or HTML file to function properly. Um, Fortunately, Rust has this crate called Shiva, which follows this common document model convention. So it parses a docx file, creates a CDM, and then generates uh, any file type you want. So I can convert docx to HTML or Markdown, or I can convert CSV to to again any any file format I want. And since it's Rust, it's blazingly fast. We'll see in the example. Okay, we'll need to be quick. We have only 15 minutes left. Here I'll create a folder. Folder Rust, and there I'll create another folder Shiva FFI to keep things clean and organized. Cargo.toml. So this is an alternative for pubspec.yaml in the Rust world. I'll just add the code here. Right, so this is a package name and version. This is important. So C dy lib. So C, dynamic library. Dynamic libraries are ones you can use as a dependency in your libraries or executables. And C specifies that it can be loaded from C and C++ languages. And here, Shiva, we are importing Shiva and its particular features, Markdown and docx, which is the file formats in this case. We want to convert only from docx to Markdown in this example. Now I can create a source folder and lib.rs. All right. Okay, now that's a bit overwhelming, but we are importing C string, which is a specific type of string we can use in C language from FFI package. We do some additional imports to program in Rust, such as pointer and the C car. We use bytes because Shiva uses bytes to create CDM. And again, docx and Markdown features. And transformer trait, which lets us parse CDM and then generate bytes from that CDM. Extern command exposes this function to FFI, so Dart can call this function. And no mangle is super important because Rust usually changes the function's name during compilation. We don't want that, so we say no mangle, and we can then use the name of the function from FFI. Then there's input pointer, which is U8 bytes, the length of the input pointer. And we just do a basic null check. Then we cut a slice from the bytes, which is basically we are creating an array, turning it into a vector. Vector is again a dynamically an array of dynamic length. And finally, we create our bytes object for to be used as input bytes in Shiva's transformer. We use docx's transformer to parse the bytes and create common document model. And once we have the doc, we use Markdown's transformer to generate the output bytes. This is the final output, but that can be readily used with Dart, so we convert it into a UTF string, UTF-8 string. That's about it. But we have one more method, which is used to free up the allocated memory during this operation. We need to call it from the Dart side because sadly Rust does not do it automatically like Dart does. So we are in the low-level language world now. I can, okay, Rust is all done. We can move to Dart now. In lib, I'll create a file called Shiva FFI.dart. Okay, I missed one step. We will get back to that. Or actually, let's just talk about it right now. After writing this program, we need to compile it. So the compilation command, first I'll need to move to the directory rust cd shiva ff, ffi, and I can run this command cargo build release to compile my code. However, it takes a long amount of time and we don't want to do that. But essentially what it will generate are um, these compiled files for each platform. It's different from for Linux, different for Mac. For Windows, we have this file called shivaffi.dll, dynamically linked library. So I'll copy this file and I'll go in build Windows runner debug. And here lies our executable for Ingenuity, and I'll paste it in here. So ideally you would write a script to do all of this, but for this talk, let's just keep things simple. I did it manually. Now I can write my Dart code. Okay. So here, again we are importing FFI, and we open the generated the compiled file like so by specifying just its name as the path because it sits next to our executable at runtime. Here are some type defs which are important to use the underlying Rust functions. The only difference between this set, like between these and these, are this input pointer, which comes from C, and int comes from Dart. So we need these type definitions in these lookup functions so that our so that Dart can use the underlying Rust functions readily. Similarly, we has this for the free memory function, like so. Now our functions are ready to be called, and this method is pretty simple. We read from the file bytes from the path. We allocate some memory for the pointer. Again, we are in C. We are working with C code now. We allocate some memory, and then we set our bytes in that memory slot, and we call the docx to md method, which comes from Rust. We free the input buffer, the input bytes used in this operation, and here finally we free up the bytes used in the Rust operation, Rust conversion operation, and this we just convert to Dart string because we don't want bytes, we want a final string to be used in our as the context in our dialog. Okay, we're almost there. Let's be quick. So I'll go to quick question dialog and scroll all the way down, and I'll implement this. So here, when I press this add context button, it will pick a file and it will convert. Oops. Okay, it will pick a file using file picker, and it will convert the file, the docx file, to markdown, and the output string is then given to the document context. You also give the name for UI update, and this document context we can see in the controller is used as the context for our LLM, which if we see the final method where it's used, repo implementation. So here it takes in the context. So if the context is present, we add to the system prompt, be concise, and also consider this context for your response. So now the LLM will use the context we generated from the docx file. I'll head back to quick question dialog and actually add this widget to to our dialog. Somewhere here, right here. This is the final piece of code. And that's it. Now if I can even hot reload because everything else is wired in. So I press shift space and we have this button. This also has the accent color, by the way. I press it and it opens up the file picker. I can upload this doc in unity.docx, which contains all the details about my application. Now if I ask it the same question we have been asking it during the talk, what does ingenuity mean? I hope I get a different answer this time. And we have about 4 minutes. Okay. Please ask your questions if you have any.
So using FFI, can I only use languages which is similar to C, which exposes a C-type ABI, or can I use Python or any other languages?
So many languages support FFI. So Python has one. There's a framework for JavaScript as well. Yeah, no, I think it's called Node FFI. So you can use.
Okay,
Yeah,
all those.
you can. So now it takes my document's context to answer my question. At its heart, engineering, creative spark and flow, whatever, whatever that is. But it is talking about my app and not the word. And that's it. I think we successfully implemented one of the most popular features in AI apps. And okay, so what we saw in the past 70 minutes, let's have a quick recap of the takeaways. We explored Flutter's plugin ecosystem to go beyond UI and get to the OS layer of things. But where the plugins didn't support our use cases, we started with exploring other approaches. So first one is external process management. So using the process API, I was able to start an Olama server and interact with offline LLM. We enhanced it aesthetically by pulling out the OS accent color and coloring the command palette. Finally, we added the add context button and the docx to markdown conversion using Rust, and we interacted with it using foreign function interface. However, all this is what we saw, not exactly what we learned. What we learned is something different. So a few months back, I saw this campaign that Apple was running, which is just 3 words, Mac does that. So basically they're encouraging users to switch to Mac and like they're saying, hey, Mac can run PowerPoints and Excel as good as your Windows machines. So Mac does that. What we saw in the last 70 minutes is not about plugins or FFI or platform channels. It's about challenging this notion that Flutter is limited in any way. So if someone tells you, hey, Flutter is only good for mobile or Flutter is only good for UI, you can confidently reply, hey, no, Flutter does that. Yeah, I'll just leave it here. You can scan this QR code to access all the resources, including the PPT, including the project with the instructions I followed from starter to the final project, and some additional resources as well. Questions are welcome. Thank you.